Hi, I'm Kevin Busarow with Oberwerk Binoculars. For many years, customers have asked if there was a go-to solution for our big binoculars. Like you see with telescopes where you'd say, I want to go to the Beehive Cluster, and it slews the telescope to that object. And there really wasn't anything available that was affordable for our big binoculars until recently. iOptron came out with their AZ Pro mount, and more importantly, a special bracket called the bino bracket that allows our binocular to attach to the mount. The base of the AZ Pro is proprietary. It's meant to attach only to iOptron tripods. So we came up with our own adapter to use the AZ Pro with our TR3 tripod. So we'll just set that up here. And there's a big 12mm bolt that attaches the mount securely. Just get that finger tight, and then there are 3 levelers to get it snug, and we want to get the mount level. There's a bubble level on the back that you can't see here that I'm looking at. Let's see. There we go. Okay. The load on the AZ Pro must be counterbalanced. So, and we need to put the counterbalances on, the counterweights on first. If we put the binocular on first, it'll be top heavy. So let's put the weights on. Now there's a pin in the weight that's going to push against the counterweight shaft. And if we put it on in this position, the pin drops down by gravity. So if we put the thumb screw to the bottom, the pin falls back, we can slide the mount on. So thumb screw to the bottom. There we go. And now we can attach our binocular. It's a dovetail plate that goes on the bottom of the binocular. It's got a stop at one end, and because the binocular is mostly going to be pointing up, we want the stop at the top so that if something slips, the binocular won't crash to the ground. Which means when we mount it, it needs to go in backwards because of that stop. So get that in, lock it down, and that looks good. Just need to attach the hand controller. This mount is fully automatic, has built-in GPS, so it can figure out where it is, time and date, so it knows where to find objects in the night sky. It first needs to go through a setup routine when we first turn it on. And part of the setup routine is to get the binocular tilted back and out of the way because the GPS sensors are in the top of the mount here. So it needs to get that out of the way so it can get a view of the sky. And it's going to make a circle as part of the calibration. And then it's going to point at one of the brighter objects in the sky. If it's for nighttime, it would probably point at Jupiter or Venus or whatever is up. And then we would use the arrow buttons to confirm. If it needs a little fine tuning, we can get that object in the center of the view. And from then on, it's very accurate. As it's doing this, watch the cable. Make sure it doesn't get tangled up. Oh, it's asking to verify the settings. Daylight savings time, yes. Time in UTC, which is Universal Time, Greenwich Mean Time. We are Eastern Time here, so it's plus 300 minutes. That's all preset. So now, because it's daylight, it wants to slew to the sun. That's the only bright object up. So if we were actually outside, we'd want to have solar filters on the binocular. We're inside, we'll just tell it, go ahead, go look at the sun. And there it goes. And again, if this were at night, we'd be looking at Jupiter, something bright that's up. Okay. Enter to confirm. And of course, I can fine tune if it's slightly off. Okay, and now it's ready to go. It's ready to start finding whatever you want to see. It's got the full Messier catalog, all kinds of objects in here. If we're using it in daylight, we can simply go to manual mode And speed 1 through 9, 9 being the fastest, 1 being imperceptible, we can then just use the arrow buttons to slew the binocular to anything we want to look at. That's it. Thanks for watching.